Let's get started. Okay. Hi, everyone. How are you doing this morning? Fine. Did you enjoy the keynotes? Yeah? Okay, cool. I'm really happy to be here. It's not my first conference. I'm a speaker for like 20 years almost, but it's my first talk with my new company. So I'm really excited about it. And basically, I will talk about self-service. Okay, developer self-service, a bit the evolution. How did we went from no self-service to self-service? And I will share with you some opinions that I have on this topic and some tips. Okay, let's start by introducing myself. I'm Sebastien Blanc. I'm half French, half Dutch. That's why I have this weird accent. Okay, I hope you will understand me. But you can call me Sebi. You can follow me on X on Sebi2706. I'm a Java developer. Yeah, we still are there. I'm a Java champion, and my job is to make developers happy. Okay, and how do I do that? By giving talks, by creating content. And beside that, I love Half-Life, the game, and cats. I have myself 5 cats. So if you want to talk about cats, Half-Life, or portals, come to me after this talk. I will be more than happy to talk about that. Okay, so what does exactly self-service mean? Okay, to try to understand that, let's do the opposite. When there was no self-service, or okay, they moved my slides. When there was no self-service. So remember, that's more or less a real life situation. That was me in 2004 when I started working. I was working in the Netherlands for a big bank. And yeah, we had no self-service. And when we had a new test environment we needed, so I was writing an email to Ops, to Elmar. Hey, could you please give me a new environment, WebSphere? Yeah, we were doing WebSphere. And yeah, the EFL is where it is, needs to be. Yeah, don't forget about the beans.xml. We need to change that. And yeah, ask Robert. He knows what to do. Okay, so I send the email. And then I got this reply from Elmar. I'm on PTO. Okay, Robert will be my backup during this time. Oh, awesome. I forward this email to Robert. Okay, hi Robert, please see the email below. Could you help me with this? Hey Sebi, sure. I plan it for next week, Wednesday, to get a test environment. Also, I'm not entirely sure how to upgrade the GDK. I will let you know. So, as you guessed, it was not really going really well. That is how we were provisioning our environments. And that was just a test environment. Production was more or less the same. Someone in the team was making the ear file on his computer. Okay, everyone could do it. We were having the DevOps culture even before it existed. And with Eclipse, and then we put that on a shared folder. We sent an email to Elmar. Hey, can you put that to production on a Friday, of course? And then we were spending the weekend with them to make things work. But the good thing was that we were only going in production twice a year, and we just had one big monolithic app. So we didn't have really that need of self-service. We didn't even knew what it would mean, self-service. So that was pretty much okay. Okay. Then we had tickets. That was a bit better, okay, because we could track things at least. But at the other side, it was a human ops most of the time. And yeah, I remember I was using that 10 years ago to request a database using ServiceNow. And yeah, you start sending a ticket and then you exchange a few comments and then you call the guy and then 2 weeks later you get your database. It's not really better, okay? And yeah, that was more or less how it was working. We had all those silos, the walls of confusion. But again, we were just going in production once or twice a year, not a really issue. Then IT started to change a little bit, okay? So what I'm showing you here now is not in the exact right order, the chronology, I'm not sure, but it doesn't really matter. It's just to show you the most important things that changed. First of all, sharing computing time and resources, okay? There was a first big move from Amazon. They realized that they had those huge data centers that were only used 100% of the time during Black Friday, okay? And one smart guy realized, hey, we could sell all this computing time. And yeah, that is how cloud native started, more or less, going to the cloud. At the same time, we had Netflix that had its on-premises solution and that crashed. And they decided, no, we don't want to do that ever again. We are putting everything in the cloud, okay? Distributed computing, because cloud native, what is cloud native? It's just distributed computing, okay? They did things like microservices, Netflix. They wrote a lot of libraries around that. They were also one of the reasons that Spring Boot, for instance, is so popular, because They were using Spring Boot, but they wrote a lot of libraries that they open source that to deal with concerns that only happens in the cloud, like elasticity, resiliency, service discovery. Okay, but there was a shift. Instead of having this big monolith, we had all those small services, microservices. Okay, that was one other big change. And then we had containers. Yeah, containers everywhere. That changed a lot for me as a developer. That made things way easier because I could really say, hey, it's working on my computer, it's working in my container, so it will work exactly the same on production. For me as a developer, it was great. For ops people, in the beginning they were happy, but then they realized they will have to deal with exactly the same issues. So it didn't solve that many things for the ops people. But again, containers was a big thing. And we had new methodologies and practices. Okay, I'm not here to talk about the whole DevOps culture, breaking the silos, etc. That was one thing. We had also, so that is more practices. And then we have also methodologies. I'm not a big fan of the whole business around methodologies. I just let you appreciate this slide deck that I really like. Okay, when I drink some water. Okay. But anyway, the way we wanted to work changed a lot. And I will stop bashing about Agile because I could go the whole day long speaking about that. DevOps promises continuous delivery, self-sufficient developers, quality, security, compliance. Yeah, that more or less happened. Let's be honest. In most companies, they were capable of infuse a bit this DevOps culture. But with all those changes, moving to the cloud, moving to containers, adding security, because security is important. Monitoring, we had a keynote this morning about monitoring and metrics and stuff like that. What happened is that me, the developer, I still had to code, okay, because that's my job, coding, cool. But I also had to manage deployments, manage incidents. I get a lot of cognitive load on my mind, okay? And it's really weird because when I was talking about 20 years ago, I didn't have this cognitive load. I just was on my Eclipse, writing my Java code, check one button to get an ER file. Cool. And now I need to code, but I also need to understand what a CI/CD pipeline is. I need to do some shift left for my containers to see if they are secure. If my team wants to implement service mesh, so I have to have a side container, and how do I do that? And I have to deal with pods and deployments. I'm a Java developer. I don't know all of this, but I still need to do it. How can we make that easier? How can we abstract that away? Example here, my developer team needs to create a new project, a new microservices. So what needs to be done? I need to create a GitHub repo with the right template, generate a token to be able to consume one of the cloud services, maybe to consume this S3 bucket there. I have code reviews, deploys, and finally going to production, because that's the most important thing. Your code doesn't mean anything until it's to production. But all those things, these are actions that me as a developer, I need to do. I forgot there was some animation on those slides. So again, just to bring again on the cognitive load of developers, bring feature to production, manage feature flags, remediate vulnerability. That's a really hard thing to me say as a Frenchman. Remediate vulnerability. These are the kind of words that French people cannot pronounce. Anyway, interact with Kubernetes. Okay. Oh, you could see here, I'm a big fan of Kubernetes, and we will talk a lot about Kubernetes. Let me check the time. Optimize costs. Yeah, me as a developer, I should not say that, but that's more for the managers. But yeah, don't forget to turn off your EC2 clusters. Okay. Incident management, we heard about that this morning as well. Understand of the AI, so a lot of things. How to offer a unified self-service, because you can see all those things. As a developer, you have 20 tabs open with all the different portals for AWS, for Git, for Argo CD, and how could I simplify that? Kubernetes, there we go. I'm a big fan of Kubernetes. I love Kubernetes not because it's an orchestrator. It's a great orchestrator. It's the best in this, okay? But what I really like in Kubernetes is it's really a base platform on which you can build things. And I think that's the most powerful feature of Kubernetes. If you're building a platform today, and that is a really opinionated way of saying that, I think you should build it on top of Kubernetes. If you don't agree, come speak with me on the booth later, today or tomorrow. So again, Kubernetes is all about defining a desired state. And that is a really powerful concept. You declare as a developer, as an ops, the state of something that you want, okay? And you apply that to a platform, and the platform makes sure that this desired state is always in sync with the reality, okay? Really simple concept, but really powerful. And you declare, so it's the declarative way. So that means that we can maybe simplify things for developers. You will see why in a few seconds. I told you Kubernetes is a base platform on which you can build things. And one of the most powerful concepts in Kubernetes are operators. Basically, you can define any resource, any custom resource, whatever you want, and you can make that part of the API of Kubernetes. Okay, and then to be sure that you have always the desired state, you implement a controller. Okay, it's just a pod running. You write it in the language that you want, okay, because it's just a pod, and you make sure to read those custom resources and to take action on your cluster. And that means that you can abstract a lot of things away for stuff that might be running in your Kubernetes cluster, or maybe stuff that runs outside your Kubernetes cluster. That doesn't really matter, because in the end, your controller, your pod, does whatever he wants. If it needs to call an external API, you just can do it. You do really what you want. But the central point is the custom resource definition. For me, the most important part when it comes to platform engineering, self-service, is you have to have a shared domain. And one way of having this is by having custom resource definitions. Okay? Before building your own operator, because I have a lot of demos. Before writing your own operator, if you need one, you probably want to check if there's already an existing operator. And the best place is probably to go to operatораpp.io, okay? And guess if I want to, I need a Kafka cluster, and I would like to run it in Kubernetes, okay? I'm allowed to say that now since I changed the company, because I was working in a company that was doing managed Kubernetes, and I was saying, who would never do that on Kubernetes? But now I can say, hey, it's probably a good idea to run your Kafka on Kubernetes. And one of my preferred operators is SREday, for instance, and they say, hey, Kafka on Kubernetes in a few minutes. And it's more or less true. Here I'm probably, I hope I'm connected to my cluster info. Let me see. Yes. So I'm running on the Sivo Q3S. Thank you, Sivo, which is giving me credits to run those kind of demos. And I have installed the operator already. It's running. And that means I've got new types in Kubernetes. So I can do kubectl get Kafka. Now he understands my cluster, understands Kafka. He says, I understand it, but there is no Kafka. Okay, so I can probably apply a Kafka. Let me see, Kafka ephemeral. Let me apply that, and then I will show you that. Let me back that. There we go. Now I can apply this kind of resources. That is CRD, custom resource, based on a CRD. And I can define a Kafka. And here, if I do a kubectl get pods, I probably see not yet what is happening. And let me just check. Get pods, Kafka. Oh, maybe I'm applying that. Did I apply that? To apply that to get Kafka. I was expecting some pods as well. My cluster. Okay, it's not the point of this demo. Okay, so I won't run a whole Kafka, but the idea is that you can really apply this. You have the same here for the topics. Okay, so if you want to create a Kafka topic, you just apply, probably have your Kafka topic. Okay, and I got my Kafka topic. Cool. So there are a lot of existing operators. But maybe at one time, you will see that you need to write your own operator. And again, it's really easy. It's more or less what I said here, okay? You need to write a custom resource definition, okay? And for me as a Java developer, it's a bit like defining my Java class, okay? And then I have my custom resources that will be instances of this class. And again, you're really free to do whatever you want. Writing your CRD, there are different ways of doing that. The great thing is that in a CRD, it's more or less the definition of your API is just an open API spec. Okay, so if you have an API team in your platform team, they can give you this open API spec and you can make it a CRD. You can also work the other way. If you can write some code and from there generate some CRDs. That's what I do when I create operators in Java, because you can write operators in Java. We have a great SDK. So if you have Java developers in your teams and you need to write operators, tell them to take a look at the Java operator SDK and the Quarkus extension. Okay, you can also generate code from CRDs. So you have your CRDs and from that you will generate your objects that you can manipulate to write your controller. And then you need to implement the reconcile loop. Okay, again, there, the frameworks, the operator SDK will help you. Most of the time, it's just implementing one method, the reconcile loop, and where you make sure that if someone deleted a service, for instance, which is part of your deployment, he deleted it directly on the cluster, he will be able to detect that and to recreate the service after that. 6 minutes, wow, that goes really fast. Just to tell you that you can, when I tell you, you can really write whatever you want. And do I have it open here? Hopefully it's the right Video Studio Code. Yes, I'm writing currently a Quake-free operator because I like Half-Life, but I like also Quake. And I was saying, hey, it will be cool to have an operator because you can run a Quake-free server on Kubernetes because, yeah, Kubernetes is great. And I say, it would be great to have an operator where I just specify the maps that I want, the minimum players. Here, that was just a demo. And from that, I can create an operator. I deploy that on my cluster. And if I go over, no, that's my email. I'm always a bit messy with my screens, as you can see. Oh, there we go. Okay, if I clear this, well, and also get a new keyboard, the enter key is really small on those Macs. If I do cube get Quake, okay, my Kubernetes cluster understands Quake now. I'm so proud of that. If I do kubectl describe my custom resource definitions called Quake, okay. Here, that is what a CRD looks like. It's a really simple one. Here you can see if for the Quake players, you can probably recognize here the different maps of Quake free. And yeah, I don't have that many time, but what I wanted to show is that I'm using Java and I'm using Quarkus. I'm able to run my operator locally. Okay, and make changes to my operator. And every time that is saved, a new CRD is generated, applied on my cluster, and I can see live the changes. Okay, that is real developer experience. That was just me again saying, hey, if you need to build operators, then you should consider writing them in Java. I don't have always the opportunity to promote Java. And now I lost my slides. Where are my slides? Okay. Writing your own operators. But at one point, the risk is that you fall back to the same issue that we had in the beginning. So you start writing one operator, then you are consuming maybe 3 or 4 vendors' operators. You have too many operators. And again, a lot of cognitive load for the user, for the developer. And maybe also the vendors' operators, they are really nice, but they expose the total surface API of their service. And maybe you as a platform engineer, you don't want to offer that to your users, your developers, okay? What can you do? You could write an operator that abstracts the vendor operator, okay? It isn't silly. In some cases, it could be. But there are now frameworks that let you compose your operators, okay? The one that I'm showing you here is called Kratex, okay? It's open source. And basically what they say is you define your CRD, like you do usually, okay? And then you can give it dependencies. And those dependencies are other operators that will be installed for you. And then you have this concept of pipelines that you have to implement. And basically, it's more or less like an operator, but it's way easier. You get a resource in, the custom resource definition that you define, that they call the promise. And then you write your pipeline where you basically spit out other CRDs, the vendors one or your custom ones. And again, you write as many pipelines that you want. Usually one pipeline will be enough. But it's really nice. You're really separating the concerns whenever you need to change to another operator vendor. For Kafka, for instance, you move from StreamZ to Ivan. You can do that here in the promise. And the user, the developer from the Streamline team won't even notice that. Kratex.io, write your own operators. But how do you make your self-service available in 2 minutes? Wow, cool. Do you give direct access to the Kubernetes clusters to your users? Cube still apply, might potential dangerous custom resource? Not sure. And maybe a lot of your developers don't even know what the kube control, kube steal, what the hell is that? Okay, maybe they don't even know. And you don't probably want them to give them access to your cluster. So again, you probably know it, but you should have a central source of truth, and you should leverage Git for that, okay? On GitHub, on GitLab, okay? I don't really care. Both are great. But the thing is, that is where you will apply your resources. You will do a custom resource like we saw before, okay? And you will commit that to a Git repo, and then a component like Argo CD will take care of that and make everything right. Everyone knows how to use Git, okay? So that's a great thing. And that way it would make life easier for developers. If they don't know how to use Git, you should probably fire them. No, I'm joking. You can provide them with other stuff like a CLI or a portal. We will talk about that in a few seconds. Wow. Do you want to expose everything in your source service components? No. Okay, I already spoke about that more or less. Hey, what about using a portal? So I got just 30 seconds to, I'm an advocate, so I'm not pushing for the product, but you should maybe consider writing an internal developer portal. You can write your own, okay? If you like CSS and front-end, good luck. And you can do that. You can, or you can choose for any portal. 9 seconds to do my demo, okay? But basically, 3 seconds. What I want to show you here, with this portal from Port, my company, I can take a question. While I take a question, what I created here. You remember my Quake 3 operator? I created here self-service action component. The portal created that for me automatically because it can read CRDs. And basically what I can say, hey, yeah, my SREday server, okay, I want those things, 15 players, 15 players, yeah, 8 players. I don't know why I'm execute, that's it, okay. That will run a GitHub action. We should see it here running in a few moments if I do, yeah, there we go. And that will basically provide a provision for me, a Quake. And yeah, the idea of the demo was, but I won't be able to show you that because we have a service catalog as well. With a bit of chance, we have probably this one that is working here. If I go there to my live server, so imagine that is the one that I just deployed, even if it's not totally true. But I click there. Sorry, dude, now I'm lost. Now I'm lost because I'm stressed, okay? I'm often stressed because clicking, there we go. Yeah, sorry. And that should, oh, there we go. Sebi joined. And while it's doing this, get Quake. We should have the SRE. Get Quake. Hey, my SRE server. So this one is ready as well. Okay, and now I'm able to play Quake, okay? And it was a bit of a challenge for me for my first conference in my new company saying, hey, I will be playing Quake. Is that okay? Just do one frag? No. Okay. Anyway, that's for me. Are there any questions? Let me just remove the sound because otherwise you will get crazy. And I'm looking for my slides again.
So I guess you can play Quake at the booth.
At the booth, well. Sure.
Thank you so much for this. Any questions? In the meantime, I would like to invite Jerome to plug in.
Oh, and next week, yeah, sorry, I'm really bad. Well, hey, scan that, please. And you will be able to, we run a developers portal meetup next week in London. So if you're in London, I will be there as well. We will be running Quake again and hopefully playing it all together. Be sure to scan that or take a leaflet on our booth. Thank you so much, everyone.